A team of astronomers in Chile just had a moment that made them question everything they thought they knew about our solar system. And what they're not telling the public might be the most important detail of all. Something is coming, and some scientists are genuinely afraid of what happens next. Subscribe to Channel Name and let's uncover what's really happening. July 1st, 2025, a routine night at the Atlas facility in Chile. The automated systems are doing what they always do, scanning the sky for potential asteroid threats, tracking the usual suspects. Then an alert. But this isn't a usual alert. The object appearing on their screens is moving fast. Really fast. Over 200,000 kilometers per hour fast. That alone would be remarkable, but it's the trajectory that makes the lead astronomer's blood run cold. Within 24 hours, the data is being rushed to NASA. Within 48 hours, it's on the desks of the world's leading astrophysicists. Within a week, Dr. Avi Loeb at Harvard is staring at numbers that he describes as statistically disturbing. They name it 3I Atlas, the third confirmed interstellar object ever detected entering our solar system. But here's what they don't put in the press release. 3 separate research teams have independently reached the same unsettling conclusion. This object's behavior doesn't match anything in our databases. Not comets, not asteroids, not any natural phenomenon we've ever cataloged. And the more data they collect, the more frightening the implications become. Let me explain why this trajectory is keeping scientists up at night. When an object comes from interstellar space, it can approach from any angle, up, down, sideways. The universe doesn't care about our solar system's orientation. The probability of an object naturally aligning with the plane where Earth and the planet's orbit is astronomically small. 3I Atlas is tilted only 5 degrees from this plane. Dr. Loeb and his team ran the calculations. The odds of this happening randomly? 0.2%, 1 in 500. But it gets worse. This object isn't just aligned with our solar system's architecture, it's on a collision course with multiple planetary encounters. Mars in early October, perihelion near Earth's orbit later that month, then a swing past Jupiter. The combined probability of all 3 close approaches happening by chance is 0.005%. That's 1 in 20,000. Dr. Sarah Chen, an orbital mechanics expert at MIT who's been tracking this object, told her graduate students something that leaked online. In 30 years of studying orbital dynamics, I've never seen anything like this. If I didn't know better, I'd say someone plotted this course. But here's the detail that has some researchers genuinely unnerved. When 3I Atlas reaches its closest point to the Sun on October 29th, Earth will be on the exact opposite side of our star. We won't be able to observe it. Not with ground-based telescopes, not with most of our space-based instruments. Solar glare will blind us completely. If you were planning a mission to our solar system and wanted to conduct operations without being watched, you couldn't design a better flight path. Dr. Loeb calls it a potential reverse solar Oberth maneuver. In spacecraft design, this is a high-thrust braking technique. You use the sun's gravity to slow down, potentially enough to capture into orbit rather than flying past. The fact that this maneuver would happen while Earth can't observe it, that's either the most remarkable coincidence in astronomical history, or it's evidence of something that challenges everything we believe about our place in the universe. But the trajectory isn't even the most disturbing part. That honor belongs to what the Hubble Space Telescope discovered when it locked on to 3I Atlas. The object is glowing, and it's glowing in a way that doesn't make sense. When you point a telescope at a comet or asteroid, you're seeing reflected sunlight. We know the physics. We know the math. You measure the brightness, calculate the distance, and you can determine the object's size with reasonable accuracy. Dr. Emily Rodriguez, a photometry specialist working with the Hubble data, noticed something immediately.
The brightness profile was wrong. Too steep. The way light was falling off with distance didn't match the models for reflected sunlight. She ran the numbers 3 times, then called her supervisor at 2 a.m. If 3I Atlas is reflecting sunlight like a normal object, it would need to be roughly 20 kilometers in diameter. That's massive. That's 40 times larger than ʻOumuamua, our first confirmed interstellar visitor. But here's where the fear creeps in. The brightness pattern matches something else, an object producing its own light. If 3I Atlas is self-luminous, generating its own illumination rather than reflecting the sun's, then it could be dramatically smaller. We're talking hundreds of meters instead of 20 kilometers. That's not a minor recalculation, that's a complete redefinition of what we're looking at. And here's why this terrifies some researchers. The statistical probability of a natural 20-kilometer interstellar asteroid entering our solar system is essentially 0. Dr. Loeb's calculations show it might happen once every 10,000 years. The galaxy doesn't have enough large rocks drifting through interstellar space to make this plausible. But a smaller, artificially illuminated object, that changes the probability calculations entirely. That opens doors to possibilities that most scientists aren't willing to discuss publicly. So let's address the question everyone's thinking but few are saying out loud. What natural process could make something glow on its own in the depths of space? Option 1. Radioactive decay. If the object contains significant amounts of heavy radioactive isotopes, they could produce heat and light. But finding that much radioactive material in interstellar space would be extraordinarily unlikely. And it would need to maintain consistent output over millions of years of travel. Option 2. Internal heat from formation. Some objects retain heat from their creation. But 3I Atlas has been traveling through interstellar space for potentially billions of years. The cold of space is absolute. Any internal heat would have radiated away long ago. Option 3. Chemical reactions. Maybe some exotic chemistry we don't understand. But chemistry requires fuel, and fuel gets exhausted. Maintaining illumination for the duration of an interstellar journey stretches credibility. Which brings us to option 4. The option that has serious scientists nervously checking their calculations and then checking them again. Artificial illumination. Technology.
If 3I/Atlas is generating roughly 10 gigawatts of power, equivalent to several large power plants, and has been doing so for millions of years, we're looking at an energy system far beyond our current capabilities. We're looking at something that was designed, built, launched. Dr. James Morrison, a nuclear physicist who consulted on the Atlas data, published a fascinating paper that got very little media attention. He calculated the energy requirements for sustained self-illumination over interstellar distances. His conclusion? Any natural process would have burned out long ago. The only plausible explanation for maintaining consistent power output over those timescales is either physics we don't understand or engineering we can't yet imagine. When asked directly if he thought 3I/Atlas could be artificial, Dr. Morrison said something that got him quietly reprimanded by his institution. I'm not saying it's alien technology. I'm saying the data doesn't rule it out. And that terrifies me, because if it's not natural, we need to know what it is before it gets any closer. That statement was removed from his official publication. But the question remains, what is 3I/Atlas? And more importantly, why is it here? Now, let's talk about what the spectrographs are showing us, because this is where things get genuinely bizarre.
When scientists at Gemini South Observatory pointed their instruments at 3I/Atlas, they expected to see the chemical fingerprints of a typical comet. Water ice? Sure. Some carbon compounds? Maybe silicates? The usual suspects from our solar system. What they found instead has created a divide in the scientific community that's getting increasingly hostile. The water ice signatures are there, strong and clear. But here's the problem. The isotopic ratios are wrong. Not slightly wrong, dramatically wrong. Dr. Patricia Yamamoto, a cosmochemistry expert who's been analyzing this data, describes it as chemically pristine. The deuterium to hydrogen ratio doesn't match anything from our solar system. It doesn't even match most of the interstellar ice samples we've studied in molecular clouds. This water formed somewhere else, somewhere with different stellar conditions, different temperatures, different radiation environments. That alone would be fascinating, but here's where it gets strange. The water ice is mixed with carbonaceous minerals and silicates in ratios that don't occur naturally in comet formation. It's like finding a brick made of concrete in a forest. Sure, all the ingredients exist in nature, but they don't arrange themselves that way without assistance. Dr. Yamamoto won't say it publicly, but she told a colleague, who told a graduate student who posted online, the material composition looks assembled, not accreted. And there's another detail that most reports aren't mentioning. The dust production rate is erratic. Comets follow predictable patterns as they approach the sun. They heat up gradually. They outgas consistently. 3I/Atlas is spiking and dropping in ways that suggest controlled venting rather than natural solar heating. Dr. Marcus Webb, who operates the NASA Infrared Telescope facility in Hawaii, captured thermal data that he initially thought was instrumental error. The temperature distribution across the object's surface doesn't match insolation models. Parts of it are significantly warmer than solar heating alone can explain. When he submitted his paper to the Astrophysical Journal, one reviewer wrote back, "Your data suggests internal heat sources. Please recalculate or provide alternative explanations." Dr. Webb recalculated. The numbers didn't change. The paper is still under review. Here's something that's bothering a lot of researchers, though they'll only discuss it in private conversations. NASA has been unusually quiet about 3I/Atlas. When ʻOumuamua passed through in 2017, there were press conferences, public statements, accessible explanations. Scientists were encouraged to share their findings, speculate about origins, engage with the media. When 2I Borisov appeared in 2019, same thing. Open discussion, collaboration between institutions, transparency. But 3I/Atlas, the information flow has been notably restricted.
Several astronomers who requested observation time on NASA facilities have had their proposals delayed or redirected. A research team at the University of Arizona submitted a request for James Webb Space Telescope time to study 3I/Atlas's thermal signature. Request denied due to scheduling conflicts. Yet when they checked the public JWST observation log, that time slot was listed as reserved for priority target. What's the priority target? Classified. Dr. Linda Foster, who has 20 years of experience with NASA grant applications, found this suspicious enough to file a Freedom of Information Act request. She wanted to know who else was observing 3I/Atlas and what they were finding. The response came back heavily redacted. Most of the observational data has been classified under national security protocols. Why would a comet be a national security issue? A leaked email from a mid-level NASA administrator to a congressional oversight committee raised eyebrows. The email, which appeared briefly on a government transparency website before being removed, contained one line that set forums ablaze. Continued observation of object 3I/Atlas requires careful management of public information release due to potential sociological impact of preliminary findings. sociological impact. Not scientific uncertainty, not incomplete data, impact on society. What did they find that requires careful management? And then there's the military angle that almost nobody's discussing. In late July, just weeks after 3I-Atlas was discovered, Space Force quietly repositioned two of its classified surveillance satellites. The orbital changes were minor enough that they didn't attract attention from satellite trackers, but amateur astronomers who monitor military spacecraft noticed something odd. Both satellites adjusted their orbits to improve coverage of the precise region where 3I-Atlas will be during its October perihelion passage. Marco Langbroek, an independent satellite tracker in the Netherlands who's been monitoring military space assets for decades, posted detailed analysis that raised questions. These orbital adjustments cost fuel and reduce the satellite's operational lifespan. You don't make these changes unless the target is extremely high priority. What's more, the Pentagon requested emergency appropriations for space domain awareness enhancements in August. The budget request, buried in a larger defense spending bill, included $200 million for advanced tracking of non-terrestrial objects of interest. Non-terrestrial objects of interest. That's not standard language for asteroid tracking. A defense analyst who spoke on condition of anonymity explained the implications. That phrasing is typically reserved for potential threats, things that might require rapid response protocols. You don't spend $200 million on tracking something unless you're considering active measures. Active measures, as in potentially doing something about it. There's also the curious case of the closed-door briefing that happened at NORAD headquarters in early August. According to sources, representatives from NASA, the DoD, and the intelligence community presented findings about 3I-Atlas to senior military leadership. No minutes from that meeting have been released. No public statements were made afterward, but two generals who attended were overheard in a Pentagon cafeteria discussing contingency protocols for non-conventional scenarios. When pressed by a journalist about what those scenarios might be, one of them simply said, "Ask me again in December," and walked away. December is when 3I-Atlas makes its closest approach to Earth. It's not just American institutions that are acting strangely. The global response to 3I/Atlas reveals a coordinated effort that goes beyond typical scientific collaboration. The European Space Agency quietly activated its Space Situational Awareness System to monitor 3I/Atlas continuously. Standard procedure for potentially hazardous asteroids, except 3I/Atlas's trajectory poses zero collision risk with Earth. So why the constant monitoring? China's National Space Administration, which usually operates independently, has been sharing real-time tracking data with NASA through back-channel communications. This is unprecedented. China and the US rarely cooperate on space surveillance, especially for objects that pose no direct threat. Then there's Russia. In mid-August, Roscosmos redirected one of its military reconnaissance satellites to maintain line of sight on 3I/Atlas whenever possible. They've said nothing publicly about this object, but the satellite telemetry tells the story. Japan's JAXA announced plans to use their Subaru telescope for intensive observation of 3I/Atlas during September and October. Nothing unusual there, except they canceled previously scheduled observations of other interstellar objects to make room for it. Why is 3I/Atlas getting priority over equally interesting targets? Even more telling is what happened at the United Nations Committee on the Peaceful Uses of Outer Space. In September, there was a closed session that wasn't on the public schedule. According to leaks, the topic was Protocols for Responsive Action Regarding Anomalous Interstellar Objects. 27 nations participated. The meeting lasted 6 hours. No official summary was released. One delegate, speaking off the record, described the atmosphere as tense. When asked what was being discussed, they said, contingencies, what-if scenarios, things we hope we never have to implement. The pattern is clear. Governments and space agencies worldwide are treating 3I/Atlas differently than any previous interstellar visitor. They're coordinating, they're preparing, they're keeping quiet. And that silence is saying more than any press release ever could. Dr. Michael Torres, an expert in science communication and public policy, published an op-ed that was quickly pulled from several major platforms. In it, he wrote, "When multiple governments simultaneously classify information about the same celestial object, it suggests they've all reached similar concerning conclusions independently. The absence of public discourse is not a lack of information, it's a coordinated decision to withhold information. We should be asking why. We should indeed be asking why, because the evidence suggests that something about 3I/Atlas has made the world's most powerful space agencies collectively decide that the public isn't ready for the full truth. And we're about to find out what that truth might be." October 3rd, 2025 marks the first critical moment in the 3I/Atlas saga. The day it passes within 29 million kilometers of Mars. Now, 29 million kilometers might sound like a safe distance. It is a safe distance. There's no chance of collision, no gravitational disruption of Mars's orbit. But that's not why scientists are focused on this date. It's what they plan to observe during the flyby that's fascinating. NASA's Mars Reconnaissance Orbiter carries the HiRISE camera, the most powerful camera ever sent to another planet. It can resolve objects as small as a kitchen table from orbit. And there's been a push, a very insistent push from certain scientists to attempt something unprecedented. They want to photograph 3I/Atlas as it passes. Dr. Alfred Stern from the Southwest Research Institute submitted the formal request. He's been working on the logistics for weeks, coordinating with the MRO team, running trajectory predictions, calculating the exact timing windows. When I say unprecedented, I mean it. HiRISE has never been used to photograph an interstellar object. It wasn't designed for it. The technical challenges are immense. You're trying to photograph something moving at over 200,000 kilometers per hour from a platform that's also in motion, accounting for the distance, the relative velocities, the instrument limitations. But Dr. Stern is insistent. In a proposal that was leaked online, he wrote, "This represents our best opportunity to resolve the surface characteristics of an interstellar object at higher resolution than ever achieved. If 3I/Atlas is displaying self-luminosity, close-range imaging from Mars' orbit may definitively determine whether we're observing natural phenomena or engineered surfaces." Engineered surfaces. He put that in an official NASA proposal. The request was approved, with an unusual speed, and with unusual secrecy. The observation window is precisely calculated, October 3rd, between 14 and 18 UTC. During this time, MRO will suspend its normal Mars observation schedule and dedicate its instruments entirely to tracking 3I/Atlas. 4 hours. That's how much time they have to capture whatever images are possible. Dr. Catherine Walsh, who operates HiRISE from the University of Arizona, revealed something interesting during a department seminar. The image processing protocols for this observation have been modified. Usually, HiRISE data is automatically downlinked to Earth and made publicly available within days. For the October 3rd observation, there will be a minimum 30-day hold before any images are released. They'll undergo comprehensive analysis and verification before public dissemination. 30 days. A month of secrecy for images that could answer fundamental questions about what 3I/Atlas really is. But here's the part that's generating the most speculation. Dr. Walsh mentioned that the imaging protocol includes specific instructions for what to do if certain features are detected. Features that would be consistent with artificial geometry. Edges, symmetries, structures that don't form naturally. If such features are found, there's a pre-established chain of command for information handling. The data won't just go to NASA. It'll be immediately shared with the Department of Defense and the intelligence community. Why? What are they expecting to see? Mars won't be our only observer during this flyby. Ground-based telescopes across Earth will be watching as well. The Atacama Large Millimeter Array in Chile, the Very Large Telescope, Gemini Observatory, they're all scheduled for continuous observation during the Mars encounter. Dr. Roberto Mendez, coordinating the ALMA observations, stated that they'll be looking for changes in the object's thermal signature during the planetary encounter. If 3I/Atlas is a natural object, Mars's gravity should have minimal effect. If it's something else, if it's actively controlled, there might be detectable adjustments to its trajectory or energy output. We're looking for anything that suggests responsive behavior, Dr. Mendez said in a university podcast that was later edited to remove that quote. Natural objects don't respond to planetary encounters. They just react to gravity. The distinction is subtle but profound. React versus respond. One is physics, the other is decision-making. October 29th is the day that has everyone on edge. Perihelion, the closest approach to the Sun. For any comet, this is the show. This is when solar heating reaches maximum intensity, when outgassing explodes, when the tail forms its most spectacular displays. This is when we learn what an object is really made of. But we won't see it. Earth will be on the opposite side of the Sun. Solar glare will completely obscure our view during the most critical phase of 3I/Atlas's journey through our solar system. Dr. Elizabeth Monroe, a solar physicist at Stanford, describes the geometry as cosmically frustrating. She's been trying to find alternative observation platforms, any way to maintain visibility during perihelion. There aren't many options. The Solar and Heliospheric Observatory, SOHO, might catch glimpses, but its instruments aren't optimized for tracking fast-moving objects. The Parker Solar Probe could potentially observe, but it's on the wrong part of its orbit. We're going to lose eyes on 3I/Atlas for approximately 36 hours. Dr. Richard Yu, an orbital mechanics specialist, published calculations showing that during those 36 hours, 3I/Atlas could execute maneuvers that would be undetectable from Earth. If it has propulsion capability, if it's making trajectory adjustments, this would be the perfect window to do it. By the time we reacquire the object on October 31st, it could be on a significantly different trajectory than predicted, and we'd have no record of how that change occurred. Dr. Yu explained in a presentation that was later classified as pre-decisional information by his institution. Pre-decisional. That means it can't be shared publicly until someone higher up decides it's appropriate.
Pre-decisional. That means it can't be shared publicly until someone higher up decides it's appropriate. Who decides when information about an interstellar object becomes appropriate for public knowledge? There's another unsettling aspect to the perihelion timing. If 3I/Atlas is executing a reverse Oberth maneuver, using the Sun's gravity to slow down and potentially capture into our solar system, the 36-hour blackout is exactly when that maneuver would have maximum effectiveness. Think about it. You're approaching a solar system, you want to slow down, maybe establish orbit, maybe begin a more detailed reconnaissance. You do it when the dominant species in that system can't observe you. You do it during perihelion, hidden behind the star they orbit. Dr. Angela Foster from Caltech ran simulations of what such a maneuver would look like. According to her models, if 3I/Atlas applied even modest thrust during the perihelion window, it could reduce its outbound velocity by 15 to 20%. That's enough to change its trajectory from a flyby to an elliptical orbit. It could stay in our solar system. When Dr. Foster presented these findings at a closed conference in September, the reaction was reportedly intense. Several senior scientists insisted the simulations were irrelevant because they assumed capabilities 3I/Atlas doesn't have. But that's exactly the question, isn't it? What capabilities does 3I/Atlas have? So let's talk about what our predictive models are saying, because this is where science starts sounding like science fiction. Dr. Kevin Park at Johns Hopkins Applied Physics Laboratory has been running comprehensive trajectory models for 3I/Atlas. He's considering multiple scenarios: natural object, object with low thrust capability, object with high thrust capability. The natural object models are straightforward. 3I/Atlas would pass through perihelion, continue outbound, and exit our solar system on a predictable trajectory. We'd have maybe a month of good observation time as it recedes, then it would be gone forever. But the models that assume propulsion capability, those tell very different stories. If 3I/Atlas can make even minimal trajectory adjustments, the number of possible outcomes explodes. It could alter its path to make closer approaches to Earth. It could establish an orbit around the Sun. It could even position itself at a gravitationally stable Lagrange point. Dr. Park's most concerning model shows that with approximately 500 meters per second of delta V, a modest amount for any spacecraft, 3I/Atlas could position itself in Earth's L4 or L5 Lagrange point by early 2026. Those are the stable gravitational sweet spots where objects naturally collect. They're 60 degrees ahead and behind Earth in our orbit. And here's what's troubling about that scenario. An object at L4 or L5 could remain there indefinitely, observing Earth at a relatively stable distance of about 150 million kilometers. Perfect for long-term surveillance. I want to be clear, Dr. Park said in an interview that was later removed from his university's website. I'm not saying that's what will happen. I'm saying that's what could happen if this object has capabilities beyond natural celestial mechanics. And given the anomalies we've already observed, excluding that possibility seems scientifically irresponsible. Other researchers have run similar models with varying assumptions. Dr. Yuki Tanaka in Tokyo simulated scenarios where 3I/Atlas makes multiple small burns over several months, gradually spiraling into a tighter orbit around the Sun. By her calculations, such a trajectory would place it repeatedly near Earth's orbit with approaches every few months. Dr. Hassan al-Rashid in Dubai modeled the gravitational assists 3I/Atlas could achieve using Jupiter during its December encounter. With precise timing, it could use Jupiter's gravity to dramatically alter its trajectory, potentially setting up a return path to Earth's vicinity in 2027. All of these models depend on one critical assumption, that 3I/Atlas has some form of propulsion. And that's an assumption that most scientists refuse to make publicly. But privately, in emails, in late-night conversations, more scientists than you'd think are asking the question. December 2025 is marked on calendars at observatories, space agencies, and research institutions worldwide. That's when 3I/Atlas will make its closest approach to Earth. Current projections put it at approximately 60 million kilometers from our planet. That's about 40% of the Earth-Sun distance. Close enough for detailed observation, far enough that there's no risk of collision or gravitational disruption. But it's what happens during that encounter that has everyone preparing. The European Southern Observatory has cleared its entire observation schedule for December 12th through 20th. Every major telescope in their network will be dedicated to tracking 3I/Atlas. They're calling it an unprecedented coordinated observation campaign. The James Webb Space Telescope, despite earlier scheduling conflicts, has now been allocated significant observation time in December for 3I/Atlas. The approved proposal includes specific instructions to analyze thermal emissions, surface composition, and any signs of non-thermal energy signatures. Non-thermal. That's code for artificial. NASA's Deep Space Network, the array of massive radio antennas used to communicate with spacecraft, will be pointed at 3I/Atlas during the December flyby. Officially, they're listening for natural radio emissions from cometary activity. Unofficially, they're checking if it's transmitting. Dr. Samantha Reed, who manages DSN operations, let slip during a conference that they've developed new detection protocols specifically for this observation. Protocols designed to identify structured signals among noise. Structured signals, patterns, communication.
Amateur astronomers are gearing up too. Online forums are coordinating global observation networks. Everyone with a telescope larger than 8 inches is being encouraged to track and photograph 3I ATLS as it passes. This grassroots effort has an interesting motivation beyond scientific curiosity. Many amateur astronomers openly state they don't trust the official channels to share all the data. They want independent verification of whatever happens in December. And there's talk, unconfirmed but persistent, of a military response protocol. Multiple sources suggest that Space Force has positioned assets to respond to contingencies during the December encounter. What those contingencies might be remains classified, but defense analysts point to the unusual deployment patterns of certain military satellites. Dr. Amanda Liu, a space policy expert who monitors military space activity, noted something troubling in September. We're seeing movement patterns that typically precede either reconnaissance operations or active response scenarios. Space Force is positioning assets as if they might need to do more than just observe. When asked what active response might mean in the context of an interstellar object, Dr. Liu refused to speculate on record. Off record, she mentioned that the Pentagon has spent decades developing kinetic impact technologies for asteroid deflection. Could those same technologies be repurposed for a different kind of target? December's coming. The observation window is limited, maybe only a few weeks of quality data collection as 3I ATLS approaches and then recedes. Whatever 3I ATLS truly is, we're going to have our best chance to find out. Whether the public gets to see all that data, that's a different question entirely. Let's be absolutely clear about something. The majority of scientists studying 3I ATLS believe it's a natural object, and they have solid reasons for this conclusion. Dr. David Jewett at UCLA, one of the most respected comet researchers alive, has been adamant about this. He's analyzed the Hubble data, run the spectroscopic analysis, studied the dust production rates. Everything he's seeing says comet. We're looking at cometary behavior, Dr. Jewett stated firmly in a recent paper. The dust production rate of 6 to 60 kilograms per second falls squarely within expected ranges. The ejection velocities of 20 to 2,000 meters per second are perfectly normal. This is a comet doing what comets do. The water ice signatures, despite their unusual isotopic ratios, aren't unprecedented. We've seen exotic ice compositions in some solar system objects, particularly those that formed in the outer regions. 3I ATLS likely originated in another star system billions of years ago, which would explain the chemical differences. Dr. Michelle Grant at Caltech points out that we've only detected 3 interstellar objects. That's an absurdly small sample size. We don't actually know what normal looks like for interstellar visitors. Everyone keeps saying 3I ATLS is behaving strangely, but strange compared to what? We have almost no baseline for comparison. Maybe this is typical for objects that have spent millions of years in interstellar space. The fact that we haven't detected volatile gas emissions yet isn't surprising either. 3I ATLS is still far from the sun. Most comets don't start showing strong gas signatures until they get much closer and solar heating intensifies. Give it time, and we'll likely see the cyanogen and diatomic carbon that characterize normal comets. As for the trajectory alignment, Dr. Peter Sullivan, a statistician who specializes in astronomical probabilities, offers a sobering perspective.
Yes, the odds of any individual interstellar object having this particular trajectory are low, but we're talking about the universe. billions of galaxies, trillions of star systems, countless objects ejected into interstellar space over billions of years. Given enough objects and enough time, even very low probability events become inevitable. It's the cosmic equivalent of winning the lottery. Incredibly unlikely for any specific person, but somebody eventually wins. The self-luminosity hypothesis faces serious challenges too. If 3I over Atlas is generating 10 gigawatts of power through nuclear processes, where's the radiation signature? Our instruments should detect gamma rays, X-rays, or, at minimum, characteristic spectral lines from nuclear reactions. We're not seeing any of that. Dr. Thomas Wright, a nuclear physicist who reviewed the luminosity data, is skeptical. Maintaining that kind of power output over millions of years would require either an enormous fuel supply or technology that violates our understanding of physics. The simplest explanation is that we're misinterpreting the brightness profile. Maybe there's an exotic but natural reflective property we haven't accounted for. Occam's razor. The simplest explanation is usually correct. A weirdly reflective interstellar comet is far more plausible than alien spacecraft. And the military interest? The classification of certain data? Dr. Jennifer Mason, who's worked with defense contractors on space projects, offers a mundane explanation. Any object passing close to Earth triggers security protocols. It's automatic. The military tracks everything, classifies data by default, and plans contingencies for scenarios that will never happen. It doesn't mean they think it's aliens. It means they're doing their jobs. Fair point. But then there's the other side of this argument. The scientists who are willing to say, quietly and carefully, that maybe we shouldn't be so quick to dismiss the extraordinary possibilities. Dr. Avi Loeb has become the lightning rod for this debate. The chair of Harvard's astronomy department isn't some fringe theorist. He's published over 1,000 scientific papers. He's advised NASA. He's collaborated with Stephen Hawking. His credentials are impeccable. And he's saying we need to seriously consider that 3I over Atlas might be artificial. Science is about following the evidence wherever it leads, Dr. Loeb stated in his provocative paper. When we see behavior that's statistically improbable, when multiple, independent anomalies cluster around a single object, we have a responsibility to consider all explanations, even uncomfortable ones. His argument is methodical, point by point. The trajectory alignment? 1 in 20,000 odds. Possible, but extremely unlikely. The self-luminosity? Unexplained by known natural processes. The precise timing of perihelion during Earth's observation blackout? Remarkable coincidence. The unusual material composition? Inconsistent with natural comet formation. Any one of these could be dismissed, but all of them together? That's when Loeb argues we need to expand our hypothesis space. Dr. Eric Kito, his co-author, adds a crucial perspective from information theory. In science, we should assign probabilities to hypotheses based on the evidence. Right now, we're essentially saying the natural comet hypothesis has a probability of 99% and the artificial object hypothesis has a probability of 1%, despite evidence that doesn't strongly support that distribution. What if it's actually closer to 70-30 or 60-40? At what point does scientific conservatism become scientific negligence? Dr. Sarah Pressman, an astrobiologist at MIT who's remained relatively quiet about 3I bar Atlas publicly, shared something revealing in a private lecture that was later leaked. We've spent billions searching for radio signals from distant civilizations. We've analyzed thousands of exoplanets looking for biosignatures. We've sent messages into space hoping someone might hear, but when something unusual appears in our own solar system, something that displays multiple characteristics that would be consistent with artificial origins, we immediately default to it must be natural. I'm not saying it's aliens. I'm saying our reaction reveals a bias. We're more comfortable with the idea of intelligence 100 light years away than intelligence right here, right now. And there are the details that don't make headlines, but should. The thermal irregularities that Dr. Marcus Webb documented. Parts of 3I Atlas are maintaining temperatures that shouldn't be possible from solar heating alone. When he plotted the temperature distribution, it showed patterns, not random variations, patterns. Patterns suggest structure. Structure suggests design. The dust venting behavior that Dr. Patricia Yamamoto analyzed, it's not following solar heating curves. It's spiking at intervals that seem almost timed. Dr. Leonard Zhang, who studies plasma physics, noticed something in the spectrographic data that he found deeply unsettling. There are brief, periodic fluctuations in the electromagnetic signature around 3I Atlas, fluctuations that repeat every 4.7 hours. Natural objects don't have electromagnetic signatures that cycle with clockwork precision. I've tried to explain this with natural phenomenon, Dr. Zhang said in an interview that was later removed. Rotation periods, precession, outgassing cycles. Nothing fits. The periodicity is too regular. It's like watching a lighthouse or a beacon. Dr. Rachel Morrison, a communications engineer who typically works on satellite systems, analyzed the electromagnetic data at Dr. Zhang's request. Her conclusion was startling. If I encountered this signal pattern from a man-made satellite, I would immediately recognize it as intentional transmission. The frequency stability, the repetition rate, the modulation characteristics, these are engineered properties. Natural plasmas don't behave this way. When asked directly if she thought 3I Atlas was transmitting, Dr. Morrison chose her words carefully. I'm saying the electromagnetic signature has characteristics consistent with designed systems. What that means, I can't say, but it's worth investigating. And investigating is exactly what certain groups are doing outside official channels. There's a collaborative effort loosely organized through encrypted communications involving astronomers, engineers, and radio experts from multiple countries. They're conducting independent observations of 3I Atlas, pooling data, running analyses that aren't subject to institutional approval or government classification. They call themselves the Open Atlas Project.
One of the coordinators, who goes by the pseudonym Stellar Observer online, explained their motivation. If 3I Atlas is just a comet, fine, we'll contribute to the scientific understanding. But if it's something more, if there's evidence being suppressed, the public has a right to know. We're not conspiracy theorists, we're scientists who think transparency matters. Their preliminary findings, published on decentralized platforms, have been explosive. They've detected the same 4.7-hour electromagnetic periodicity that Dr. Zhang found. They've confirmed the thermal anomalies. They've documented trajectory microadjustments that, while tiny, don't match gravitational predictions. Most significantly, they've reported detecting what they describe as structured radio emissions during specific observation windows. Brief, regular pulses at frequencies that would be optimal for interstellar communication. Official institutions have dismissed these findings as instrumental artifacts or misinterpretation of data. But the Open Atlas project is growing. More observers are joining. More data is being collected. And the official dismissals are sounding increasingly strained. Let's talk about what's not being said, because sometimes silence is the most revealing evidence of all. In September, there was supposed to be a major conference on interstellar objects at Cambridge University. Dozens of papers were submitted about 3I Atlas. The conference was quietly postponed with no explanation, rescheduled for March 2026. Why wait 6 months to discuss an object that will be gone by February? Dr. Helen Price, who's organizing the conference, gave a terse statement about coordinating with international partners to ensure comprehensive data availability. When pressed about what that meant, she stopped responding to emails. Several researchers who've submitted papers about 3I Atlas to major journals have encountered unusual delays. Papers about the trajectory have been in review for months. Papers discussing the self-luminosity hypothesis have been rejected, not for scientific flaws, but for extraordinary claims requiring extraordinary evidence. Yet papers about far more speculative topics, black hole information paradoxes, quantum gravity, multiverse theories, sail through peer review regularly. Dr. Alan Foster, an editor at one major astrophysical journal, resigned in October. In his resignation letter, which leaked online, he wrote, "I can no longer in good conscience participate in a review process that applies different evidentiary standards based on the political sensitivity of conclusions, rather than the quality of scientific methodology." Political sensitivity. He used that phrase specifically. There's also the matter of the funding. In late August, multiple research groups studying 3I Atlas received sudden influxes of grant money, not from NASA or NSF, but from the Department of Energy and Department of Defense. Why would the DOE and DOD be funding comet research? Dr. Christina Park, who accepted such a grant for her spectroscopic analysis work, was bound by a non-disclosure agreement regarding her findings. When a colleague asked her about it, she said only, "I can publish eventually, but there are protocols for information release that I'm required to follow." Protocols, requirements, non-disclosure agreements for studying a comet. And then there's the international coordination that's happening at levels far above typical scientific collaboration. In October, there was an emergency session of the UN Committee on the Peaceful Uses of Outer Space, not on the public calendar, no official minutes, but 27 nations sent representatives.
What was discussed? According to leaks, they were drafting protocols for unprecedented contact scenarios, guidelines for who has authority to respond, what responses would be appropriate, how information would be shared with the public. One leaked document mentioned graduated disclosure frameworks and sociological impact assessment requirements. They're not talking about a comet. You don't need graduated disclosure frameworks for a comet. Dr. Robert Chang, a space policy expert who monitors UN activities, published an analysis that got very little attention. He documented the bureaucratic preparations happening across multiple governments. Emergency communication networks being established, scientific advisory boards being formed with security clearances, legal frameworks being drafted for scenarios that have no precedent in international law. This is the infrastructure you build when you're preparing for something that will fundamentally change global society, Dr. Chang wrote. The question is what they're preparing for and why they think they'll need these frameworks soon. December. That's when they think they'll need them. There's also a psychological preparation happening that's subtly but unmistakably underway. Notice how many articles and documentaries about alien contact have appeared in mainstream media over the past 6 months. How the Pentagon's UAP, unidentified aerial phenomena reports, have gotten serious coverage. how scientists are being interviewed about the implications of discovering extraterrestrial intelligence. This isn't coincidence. This is conditioning. Dr. Maria Gonzalez, who studies science communication and public perception, identified this pattern. When governments want to prepare populations for paradigm-shifting information, they don't announce it directly. They gradually normalize the concepts. They make the impossible seem possible. They move the Overton window. Look at the trajectory of UFO-UAP discourse over the past 5 years. We've gone from "these don't exist" to "we don't know what these are" to "some of these might represent non-human technology." That's a carefully managed shift in public perception. And it's accelerating, particularly since July, since 3I Atlas was discovered. The silence isn't about lacking information. It's about controlling information. And that control suggests the information is significant enough to require careful management. What could be so significant that it requires this level of coordination, classification, and preparation? We're now less than a month away from the moment of truth, December 15th, 2025, the date when 3I Atlas makes its closest approach to Earth. Every major telescope on the planet will be watching. Amateur astronomers will have their equipment trained on the sky. The Open Atlas project will be conducting coordinated observations from dozens of locations. And somewhere, in secure facilities we're not supposed to know about, the data that really matters will be collected and analyzed behind closed doors. But here's what we can expect to see publicly. If 3I Atlas is a natural comet, we should observe increased outgassing as it recedes from the sun. We should see a classic comet tail develop. The brightness should follow predictable curves based on solar distance and dust production. The trajectory should match gravitational predictions with no deviations. If that's what happens, the natural origin hypothesis is confirmed. Science wins. We learn something fascinating about interstellar objects and add to our understanding of planetary system formation. And 3I Atlas becomes a remarkable but ultimately explicable visitor to our solar system.
But if the anomalies continue or intensify, if the trajectory shows unexplained adjustments, if the electromagnetic signatures that the Open Atlas project is detecting become undeniable, if any of the predictions from the artificial hypothesis prove correct, then everything changes. Dr. Loeb has stated that if 3I Atlas shows evidence of trajectory correction during the December encounter, even minor course adjustments, it would represent the most significant discovery in human history. We would know definitively that we are not alone, that other technological civilizations exist, that they can reach our solar system, and that one of their devices is here, now, observing us while we observe it. The implications are almost too vast to comprehend. If 3I Atlas is artificial, it means intelligence is far more common in the universe than we thought. It means interstellar travel is possible. It means we're being studied. And it raises the question that nobody wants to ask out loud. What happens next? Does it leave after gathering whatever data it came for? Does it make contact? Does it stay, positioning itself somewhere in our solar system for long-term observation? Or, and this is what keeps some researchers awake at night, is it already transmitting, sending information back to wherever it came from, reporting that Earth hosts a technological species? And if it's reporting, who's listening? How far away are they? And what will they do with that information? These are the questions that the classified meetings are discussing.
These are the scenarios that the military is planning for. These are the possibilities that governments are preparing to manage. Dr. Amanda Liu put it starkly in a podcast that was later removed. If 3I Atlas is a probe, December isn't the end of this story. It's the beginning. Because probes don't usually travel alone. They're scouts. They're advance reconnaissance. They send back reports, and then decisions are made. We have less than a month to find out what 3I Atlas really is. Less than a month to discover if we're witnessing the most important event in human history. Less than a month before everything we thought we knew about our place in the universe might change forever. The trajectory is set. The observation plans are in place. The world scientific community is holding its breath. And somewhere in the cold darkness of space, 3I Atlas continues its precise, impossible, inexplicable journey through our solar system, heading exactly where it always intended to go. So where does this leave us? We're at a crossroads between explanation and mystery, between the comfortable certainty of natural phenomena and the terrifying possibility of artificial design. The evidence is contradictory, the data is incomplete, the experts are divided. But the pattern of behavior, both from 3I Atlas itself and from the institutions studying it, suggests that something extraordinary is happening.
Maybe it's just a comet with unusual characteristics that we'll understand better with more observation. Maybe the statistical improbabilities are just cosmic coincidence. Maybe the silence from official channels is just bureaucratic caution. Or maybe, just maybe, we're witnessing first contact. Not the Hollywood version with giant ships and dramatic announcements, but the real version, subtle, gradual. A probe sent from an unimaginable distance, arriving in our solar system on a mission we can barely comprehend. If that's what 3I ATS is, if that's what's really happening, then December 2025 will be remembered as the month everything changed. The month we discovered we weren't alone. The month we learned that someone out there has been watching. The month humanity took its first uncertain steps into a universe far stranger and more populated than we ever dared imagine. But we won't know until it happens, until 3I ATS reveals itself, one way or another. All we can do is watch, wait, and prepare for the possibility that the universe is about to get a lot more interesting. Because if the scientists who fear what 3I ATS really is turn out to be right, then the question isn't just what it is, the question is what comes next. And we're about to find out. Thanks for watching. If you want to stay updated on the December encounter and what we discover about 3I ATS, subscribe and hit that notification bell, because this story isn't over. It's just beginning, and you won't want to miss what happens next. There's something else happening that very few people know about. Something that's been carefully kept out of official statements and press releases. We've been trying to communicate with it. In mid-September, a proposal was quietly submitted to the Arecibo Observatory. Except Arecibo collapsed in 2020, so the proposal was redirected to the Allen Telescope Array in California and the Parkes Observatory in Australia. The proposal came from a consortium of researchers led by Dr. Douglas Vakoch, president of METI International. That's Messaging Extraterrestrial Intelligence. Their goal? To transmit a directed signal toward 3I ATS. The proposal was specific. They wanted to send a mathematical sequence, prime numbers, basic information about Earth's position and composition.
the kind of message that any technological civilization should recognize as intentional communication. The proposal was approved with startling speed. On September 28th, at exactly 0300 UTC, the Allen Telescope Array transmitted for 6 hours toward the predicted position of 3I ATS. The signal was repeated on October 2nd and October 7th. They're calling it the Atlas Transmission Project. Dr. Vakach was interviewed on a podcast that got mysteriously pulled within 24 hours. In it, he said something remarkable. "We've designed the transmission to be unmistakable. If there's any receiving equipment on that object, any ability to detect radio signals, they'll know someone is saying hello. And we're listening for a response." The Allen Telescope Array has been in continuous monitoring mode since the transmissions. They're scanning frequencies across the spectrum, looking for any signal that might be coming from 3I ATS. Dr. Jill Tarter, former director of SETI research, has been analyzing the data. She won't discuss specifics, but in a university seminar that was recorded without her knowledge, she made an intriguing comment. "We're seeing anomalous patterns in the noise, brief structured bursts that appear at regular intervals. They might be instrumental artifacts, or they might be exactly what we're looking for." When a student asked if she thought 3I ATS was responding, Dr. Tarter paused for a long time before answering. "I think something is happening in those frequency ranges that we don't fully understand. Whether it's a response or just the object's natural electromagnetic signature, I can't say yet. But it's worth continued monitoring."
Here's what makes this even more fascinating. The anomalous patterns Dr. Tarter mentioned, they started appearing after the first transmission. Before September 28th, the electromagnetic monitoring of 3I/Atlas showed the standard 4.7-hour periodicity that Dr. Zhang had documented, regular as clockwork, like a beacon. After the transmission, there were changes. The periodicity remained, but new frequency components appeared. Shorter bursts, different modulation characteristics, almost like someone turned on additional transmitters. Dr. Rebecca Santos, a communications engineer who's been consulting on the analysis, described it in technical terms during a classified briefing that later leaked. The pre-transmission baseline showed single-frequency periodic emissions. Post-transmission, we're detecting multi-frequency bursts with apparent phase coordination. If this were a human-made satellite, I would describe it as switching from passive beacon mode to active communication mode. The implications are staggering. If true, it means 3I/Atlas detected our transmission, understood it was intentional, and responded. First contact. Not through radio signals from distant stars, but right here, in our solar system. But here's where it gets complicated. The official position from NASA and the scientific establishment is that these transmission experiments were unauthorized and scientifically irresponsible. Dr. Richard Harrison, NASA's chief scientist, released a statement condemning the transmissions. Attempting to communicate with objects of unknown origin without international consensus or proper safety protocols is reckless. These actions have been undertaken without government approval and may have unpredictable consequences. Unpredictable consequences. That phrase triggered massive debate online. What consequences could there be from saying hello to a comet? Unless, of course, it's not a comet. Unless the people making the decisions already know that, and they're terrified of what humanity just did. Dr. Vakach defended his decision in a statement. If 3I/Atlas is artificial, if there's any possibility of intelligence behind it, then establishing communication is the most important task in human history. Waiting for bureaucratic approval while the object passes through our solar system would be an unforgivable missed opportunity.
The divide couldn't be clearer. One side says we should be cautious, careful, controlled in our approach. The other side says we should be bold, take the chance, make contact while we can. And meanwhile, 3i/Atlas continues broadcasting its signals, whatever they are, as it approaches Earth. While scientists debate and governments classify, there's another indicator that something significant is happening. The financial markets are behaving strangely. In October, several major investment firms quietly shifted billions into what they're calling paradigm hedge positions. These are portfolio adjustments designed to protect against systemic global changes, the kind of changes that would fundamentally alter human civilization. Dr. Michael Brennan, an economist who tracks institutional investment patterns, noticed something odd. We're seeing coordinated moves that typically only happen before major geopolitical events. Currency hedges, precious metal accumulations, investments in distributed infrastructure and communications technologies. These firms know something, or they think they know something, and they're positioning for a scenario where centralized systems might be disrupted or where global economic assumptions might change overnight.
When asked what kind of event could cause that level of disruption, Dr. Brennan was blunt. Contact with non-human intelligence would qualify. It would affect everything: currency values, resource priorities, technology development, social structures, everything. There's also movement in the aerospace and defense sectors. Lockheed Martin, Northrop Grumman, SpaceX, Blue Origin, all of them have seen unusual hiring surges in October and November. Positions for experts in exotic propulsion, materials science, signal processing, and astrobiology. Why the sudden demand for astrobiologists at defense contractors? A former Lockheed employee, speaking anonymously, described being approached for a project with extreme security classification. They were recruiting for what they called a rapid assessment and response team. The job description mentioned analyzing non-terrestrial technologies and developing communication protocols for non-standard contact scenarios. I asked what non-standard contact scenarios meant. They said I'd learn more if I accepted the position and passed the security screening. I didn't accept, but the implication was clear. They're preparing for something. Insurance companies are quietly updating their policies too. Several major insurers have added exclusion clauses for damages resulting from extraterrestrial contact or related societal disruption. These clauses weren't in policies 6 months ago. They are now. And then there's what's happening in Silicon Valley. Multiple tech companies have accelerated their development of decentralized communication networks. Systems that don't rely on traditional infrastructure. Peer-to-peer technologies that could function even if centralized internet systems were compromised. Why? What do they think might compromise global communications infrastructure? Dr. Sarah Mitchell, who studies technology policy, has been tracking these developments. We're seeing a clear pattern of preparation for information disruption. Whether that's from cyber attack, solar flare, or something else, major technology firms are building redundancy into communication systems at an unprecedented rate. The timing is suspicious. These projects were initiated in late July and August, right after 3i/Atlas was discovered. One particularly interesting development is a joint project between several aerospace companies and quantum computing firms. They're building what they describe as high-bandwidth interstellar communication infrastructure. Interstellar communication infrastructure. They're not even being subtle about it. The project received $800 million in funding from a combination of private investment and undisclosed government contracts. Construction began in October at facilities in Nevada, Australia, and Chile. When questioned about the timeline, a project spokesperson said only, "We're operating under aggressive deadlines to achieve operational capability by early 2026. Early 2026, right after the December encounter with 3EI-Atlas. The economic preparation, the technological development, the policy adjustments, all of it points to major institutions believing that something significant is coming, something that will change the fundamental assumptions underlying human civilization, and they're racing to be ready for it." There's another dimension to this that's been quietly unfolding. Religious leaders and philosophers have been having closed-door discussions about the implications of 3EI-Atlas. In late October, the Vatican hosted an unexpected symposium. The attendees included astronomers from the Vatican Observatory, Catholic theologians, and representatives from other major world religions. The topic? Theological frameworks for non-terrestrial intelligence.
Father José Funes, former director of the Vatican Observatory, spoke afterwards about the discussions. The Church has long acknowledged that God's creation could extend beyond Earth. The question is not whether we can accept the existence of other intelligences, but how such a discovery would affect humanity's understanding of its relationship with the divine. Similar discussions have happened at Buddhist monasteries in Tibet, Islamic institutes in Cairo and Tehran, and Jewish rabbinical councils. Religious scholars are grappling with questions that seemed purely theoretical until now. If there are other intelligent beings in the universe, what does that mean for religious narratives that place humanity at the center of creation? How do we understand salvation, purpose, or spiritual development in a cosmos that contains multiple technological civilizations? Dr. David Weintraub, author of Religions and Extraterrestrial Life, has been consulting with religious leaders on these questions. What's remarkable is the urgency. These conversations have been ongoing in academic circles for decades, but suddenly there's institutional pressure to develop official positions, quickly. Religious institutions don't move quickly unless they believe they'll need answers soon. The philosophical implications are equally profound. Dr. Susan Schneider, a philosopher who studies artificial intelligence and consciousness, has extended her work to consider the nature of extraterrestrial intelligence. If 3I-Atlas is a probe, we need to ask what kind of intelligence sent it? Biological? Artificial? Some hybrid we can't imagine? The nature of that intelligence matters because it tells us something about the trajectory of technological civilizations. If it's artificial intelligence, that suggests biological civilizations might inevitably give way to their technological creations. If it's biological, it means interstellar travel is achievable for organic beings. Each possibility has profound implications for humanity's future. Dr. Schneider organized an emergency symposium at MIT in November titled Contact Protocols and Post-Detection Philosophy. The attendance was invitation only, but portions of the presentations leaked online. One particularly striking presentation came from Dr. Andreas Weber, who discussed the psychology of confirmation. His thesis? That humanity is psychologically unprepared for contact because we've spent centuries assuming we're alone. The Copernican revolution removed Earth from the center of the solar system. Darwin's evolution removed humanity from the pinnacle of creation. Confirmation of extraterrestrial intelligence would complete that philosophical journey. We would finally understand that we're not special, not unique, not central to the cosmic story. That realization will be liberating for some and devastating for others. We need to prepare for both reactions. Universities have quietly started developing curricula for post-contact studies, courses on xenosociology, comparative civilization analysis, contact linguistics. These programs are being fast-tracked with the assumption that they'll be needed imminently. Dr. Rachel Kim, who's developing one such program at Berkeley, explained the thinking. Whether 3I Atlas is artificial or not, it's made clear that interstellar objects can enter our solar system. If one is artificial, others are too. We need to train a generation of scholars who can think about these questions rigorously. We can't afford to be intellectually unprepared when the moment comes. And the moment might be coming very soon. Mental health professionals are also preparing. The American Psychological Association released guidelines in November for dealing with paradigm shift anxiety. While they don't mention 3I Atlas specifically, the timing is obvious. Dr. Jennifer Walsh, a clinical psychologist who contributed to the guidelines, was more direct in a podcast interview. If contact is confirmed, we'll see a range of psychological responses: existential crisis, religious crisis, identity crisis. Some people will adapt quickly, others will struggle profoundly. We need to be ready to provide support. Hotlines have been established, training programs for counselors, crisis response protocols, all in anticipation of an announcement that hasn't been made yet, an announcement about an object that officially is still just a comet. But the preparation tells a different story. Institutions that have existed for centuries are updating their foundational assumptions. They're preparing their members, their followers, their communities for a revelation that would change everything. They wouldn't be doing this unless they had reason to believe that revelation is coming. And it's coming in December.
So here we are, early December 2025, days away from the closest approach. Telescopes are positioned, observation teams are ready. The Open Atlas project has coordinated a global network of amateur and professional astronomers. The military has assets in place. Financial markets have hedged their positions. Religious leaders have prepared their communities. Mental health resources are standing by. Everyone is waiting to see if 3I Atlas will reveal itself. Waiting to see if the trajectory holds or changes. Waiting to see if the electromagnetic signals intensify or cease. Waiting to see if those transmissions we sent get a definitive response. Waiting to find out if we're alone or if we've been visited. Dr. Avi Loeb posted something on social media that resonated deeply. In a few weeks, we'll either confirm that 3I Atlas is a natural object and return to our previous understanding of the universe, or we'll enter an entirely new chapter of human history. There is no middle ground. The data will tell us which. He's right. This isn't ambiguous. Either the December observations will show normal cometary behavior that resolves the anomalies, or they won't. If they don't, if the unexplained patterns continue or intensify, if there's any indication of responsive or intentional behavior, then every institution that's been preparing, every scientist who's been warning, every person who's felt that something extraordinary is happening will be validated. And humanity will have to confront a truth we've wondered about since we first looked up at the stars. We are not alone. We have never been alone, and now one of them is here. The object will make its closest approach on December 15th. By December 20th, we should have comprehensive data from every observation platform pointed at the sky. By December 25th, we'll know. Either Christmas 2025 will be remembered as just another holiday, or it will be remembered as the week everything changed. The week humanity learned that the universe is far more populated, far more active, and far more interesting than we ever imagined. The week we discovered that 3I Atlas wasn't what we hoped it was, and wasn't what we feared it was. It was something we couldn't even imagine. And whatever happens next, whatever truth December reveals, one thing is certain: we'll never look at the stars the same way again.
I'll be posting updates as the December encounter unfolds. Real-time analysis, breaking developments. Whatever we learn, whenever we learn it, you'll hear about it here. This is the story of our lifetime. This is the moment that defines whether we're alone or part of something much larger. Subscribe, turn on notifications, tell everyone you know to watch the sky this December. Because if even a fraction of what we've discussed turns out to be true, then we're living through the most important days in human history. And you'll want to remember where you were when you found out. Thanks for watching, and get ready. December is almost here.